A gasoline car and an electric car may look almost identical from the outside, but underneath the body, they're completely different machines. A traditional gasoline engine creates power through hundreds of moving parts, explosions happening thousands of times every minute, and a complex transmission system that changes gears to keep the car moving. But an electric car does something completely different. It takes electricity stored inside a battery, sends it through powerful electronics, and transforms it directly into motion. No fuel combustion, no exhaust, no waiting for gears to shift. Just instant power the moment you press the accelerator. But how does electricity stored inside a battery become enough force to move a vehicle weighing more than 2 tons? To understand that, we need to look inside the 4 main systems that make an electric car work: the battery pack, the battery management system, the inverter, and the electric motor. Every electric car starts with one essential component: the battery pack. Think of the battery as the fuel tank of an electric vehicle. But instead of storing gasoline, it stores electrical energy. Most modern EVs use lithium-ion batteries, the same basic technology found in smartphones and laptops. However, an electric car needs thousands of times more energy than a phone. So instead of using one large battery, manufacturers combine thousands of small battery cells together. These individual cells are connected into groups called modules. Then multiple modules are combined to create one large battery pack. This massive battery pack is usually installed underneath the vehicle floor. This location has 2 major advantages. First, it saves space. Second, it places the heaviest part of the car very low to the ground, which improves stability and handling. But storing so much energy creates a major challenge: temperature control. Batteries are sensitive. If they become too hot, they can lose performance and age faster. If they become too cold, they cannot deliver energy efficiently. This is where the battery management system, or BMS, becomes extremely important. The BMS is like the intelligent brain of the battery. It constantly monitors thousands of battery cells, checking their temperature, voltage, and charging condition. Imagine having thousands of small water tanks connected together. The BMS makes sure every tank has the right amount of water and prevents any tank from overflowing. In the same way, the BMS keeps every battery cell working safely and efficiently. It controls charging speed, manages cooling systems, and protects the battery from damage. Without the BMS, an EV battery would be like a powerful engine without any safety controls. Now we have stored electricity inside the battery. But there is a problem. The battery produces DC electricity, also called direct current. However, the electric motor inside most EVs needs AC electricity or alternating current to operate. This is where the inverter comes in. The inverter works like a translator. It takes the language of the battery and converts it into the language the motor understands. But the inverter does much more than just convert electricity. It controls exactly how much power reaches the motor. When you press the accelerator pedal, you're not directly controlling the motor. Instead, sensors detect your input and send information to the vehicle's computer. The computer then tells the inverter how much electricity the motor needs. If you gently press the pedal, the inverter sends a small amount of power. If you push the pedal harder, the inverter increases the electricity flow and gives you stronger acceleration. This process happens extremely quickly, thousands of times every second. That is why electric vehicles feel so smooth and responsive. In a gasoline car, power delivery depends on fuel injection, combustion, engine speed, and gear changes. But in an EV, the accelerator communicates almost directly with the motor through the inverter. It is a much simpler and more efficient system. Now we reach the component that actually moves the car: the electric motor. Inside the motor are 2 important parts: the stator and the rotor. The stator is the stationary part containing coils of wire. The rotor is the rotating part connected to the vehicle's wheels. When electricity flows through the coils inside the stator, it creates a rotating magnetic field. This magnetic field pushes and pulls against the rotor, causing it to spin. That spinning motion is transferred to the wheels, and the car moves forward. The amazing thing about electric motors is their simplicity. A gasoline engine needs pistons, valves, fuel injection systems, spark plugs, and many other mechanical components. An electric motor has far fewer moving parts. But the biggest advantage of electric motors is torque. Torque is the twisting force that gets a vehicle moving. A gasoline engine usually needs time to build power. It has to increase RPM and sometimes shift gears. But an electric motor can deliver maximum torque almost instantly. That is why even many affordable EVs can accelerate surprisingly quickly. The moment you press the accelerator, the motor immediately creates a magnetic force that pushes the vehicle forward. Because electric motors are so efficient, most EVs do not need traditional multi-speed transmissions. Less complexity means less maintenance and fewer parts that can wear out. Electric cars have another clever technology that improves efficiency: regenerative braking. In a traditional gasoline car, when you press the brake pedal, the vehicle's movement is converted into heat through the brake pads. That energy is simply lost into the environment. But EVs can recover some of that energy. Here's how it works. The electric motor normally uses electricity to create movement, but it can also work in reverse. When you slow down, the spinning wheels can turn the motor. The motor then acts like a generator, converting movement back into electricity. That recovered energy is sent back into the battery. This process is called regenerative braking. It is especially useful in city driving, where cars constantly accelerate and slow down. Some electric cars even offer one-pedal driving. This means when you lift your foot from the accelerator, the car automatically slows down while recovering energy. It makes driving smoother and helps increase the vehicle's range. So, how does an electric car actually work? The battery stores the energy. The battery management system keeps the battery safe. The inverter controls and transforms electrical power, and the electric motor converts that energy into motion. It is a surprisingly simple idea compared to traditional engines. But behind that simplicity is years of advanced engineering, software, and battery technology. Electric vehicles are changing the way we think about transportation. They're not just replacing gasoline with electricity. They are creating a completely new generation of smarter, more efficient machines. If you enjoyed this explanation, subscribe to MotorMind for more videos about the technology behind the cars of today and tomorrow. And let us know in the comments, what EV technology should we explain next?